Vietnam is currently one of the busiest tech manufacturing hubs on the planet. Millions of devices roll off these massive production lines every single day. But there is a mathematical ceiling to this success. Right now, the country is caught in the outsourcing trap. These factories are primarily tasked with assembly, putting together parts designed, patented, and owned by someone else. This is a chart of the global value chain. The bottom tier, assembly and outsourcing, captures the lowest fraction of global profits. All the real wealth is generated in the tiers above it, where research, engineering, and intellectual property occur. As long as a nation only builds what other countries invent, it remains a replaceable labor force. To capture real economic power, a developing market must learn how to design the core components itself. The global economy is accelerating into an environment of hyperconnectivity. 5G, 6G, and the Internet of Things all rely on a precise hardware bottleneck: advanced antennas. Specifically, the technology that integrates antennas directly onto microchips. These arrays serve as the invisible nervous system of the modern world, transmitting the vast oceans of data required for smart devices to function. In the current geopolitical landscape, relying entirely on foreign corporations to design these communication nodes means handing over control of your own digital infrastructure. To jump from the factory floor to the highest tier of the value chain, Vietnam must achieve complete antenna autonomy. This is the exact problem tech firm TMA and its CEO, Dr. David Nghiem, are attempting to solve. Instead of building another assembly plant, they are importing the intellectual architecture to build a deep tech brain trust from scratch. The first requirement is a world-class R&D laboratory. You cannot design advanced radio frequency systems on a chalkboard. Engineers need access to anechoic chambers like this one, lined with wave-absorbing spikes, to physically calibrate high-frequency signals with absolute precision. The hardware is useless without a human element. The strategy pairs top engineering experts from the US directly with young Vietnamese engineers, running them through rigorous mentorships in complex 3D simulation and hyper-frequency circuit design. It is a deliberate pipeline designed to take raw mathematical talent and forge it into the ability to produce commercially viable technical designs. In deep tech research, the deadliest threat isn't a lack of talent. It is the friction of administrative bureaucracy. Developing hardware means constantly importing highly sensitive testing equipment, like these vector network analyzers. Right now, standard customs procedures can trap these vital instruments at the border for months. By the time the equipment clears, the rapid prototyping cycle is broken, and the technology is often obsolete. To survive, R&D centers require the government to establish a green channel, a fast-track administrative lane that immediately clears specialized testing equipment for non-commercial research. In the global tech race, regulatory speed is just as critical as engineering capability. Slow customs actively kill domestic innovation. Even with a perfect lab, a nascent domestic startup can be easily crushed by the massive financial power of global monopolies, who possess the capital to dump cheap products onto the market and starve out new competitors. The second policy is market creation. By mandating domestic telecom companies buy local antennas first, the government forms a protective shield, guaranteeing cash flow. This protection is temporary, phasing out as the firm meets strict quality metrics, forcing the company to stand on its own. Securing those early domestic clients provides the essential real-world feedback loop. Without that initial proof of concept at home, no local technology can survive long enough to compete on the international stage. If those two policies, the green channel and market creation, are locked in, TMA has engineered a strict, accelerated 5-year roadmap to autonomy. Year 1 is foundational, importing machinery and training 50 core engineers. In years 2 and 3, the center leverages the domestic market, supplying antennas for local 5G. By years 4 and 5, maturity is reached, exporting premium designs to the US, EU, and Japan. It is a calculated, mathematical progression designed to move a domestic industry to the top tier of the global value chain. The timeline is critical because the global geopolitical map is currently being redrawn. Decades-old tech supply chains are actively fracturing and relocating right now. Regional competitors like India, Malaysia, and Thailand are well aware of this shift. They are rapidly rewriting their own legislation to offer the flexible policies required to capture these deep tech R&D projects. If Vietnam attempts to navigate this rapid migration using outdated administrative procedures, progress grinds to a halt, and this window of opportunity will close permanently. Establishing a domestic R&D hub acts as a strategic economic hack. It allows a developing nation to transcend the limitations of the assembly line and claim its position as an architect of the global future.